Hello class, welcome to the lesson for today. This is physics. We are looking at sound. In our last lesson, we were looking at waves. We discussed what waves were, the two main types of what we call mechanical waves, the longitudinal waves and transverse waves, their properties and all that. Then we looked at the wave equation and how to work out mathematical concepts related to waves. This one topic, we're looking at sound, which is a specific type of wave. Okay, so in the lesson we will be looking at the meaning of sound, a few terms that we can relate to waves. We'll talk a bit about properties of waves, and then we'll have a few worked out examples, and we'll have more on this topic of sound in the next lesson. So what is sound? Sound is first and foremost a longitudinal wave. We had said that we do have two types of mechanical waves. The transverse waves, which have crests and troughs. Those are transverse waves. Longitudinal mechanical waves have what we call compressions, the region where the matter through which sound is moving, wave is moving, are very close, and rarefactions, regions where the molecules through which the sound wave is moving are a bit far apart. So, and we did give an example of a sound as longitudinal wave because it's produced from air that's coming from the body or through what we call the voice box. Here, it is making it move up and down. And we did say that in longitudinal wave, the wave moves in one direction, but particles move back and forth, parallel to the direction of wave. So that's it. Then, we say that sound is created by a disturbance or vibrating bodies, and it is transmitted through a medium. Now I'll give an example here. For there to be sound produced, there has to be like this disturbance here. My two hands coming close together, they cause some kind of vibration. That vibration back and forth gives the sound. The faster, the more energy I use, the higher the sound that comes about. Or if I use this half meter rule here, I hit the desk here or the bench here. Now sound is produced because the moment this hits here, it kind of moves back and forth, and that disturbance causes the back and forth motion, which brings about the compressions and rarefactions. Then it is transmitted through a medium. In this case, the medium is air. For the sound to come from my clap or from the half meter rule hitting the table, you can hear it because the vibration of back and forth causing compression and rarefactions is transmitted through air all the way to the ear. And the ear can be able to perceive it because of nerves, transmission by nerve, and the brain. That's about sound. A bit of the intro on that. So what are the properties of sound? Sound can be reflected. We'll talk more about this in our next lesson. Reflection means I produce sound, it hits an obstacle like a wall and comes back. We call that echo. Echo. When sound is reflected back, when it is an obstacle and reflected back, we call that echo. Okay? Again, sounds can undergo refraction. We'll have more again about this in next lesson, but now what I mean is when a wave moves from a particular medium to another medium of a different property, it will be refracted. Very common for this with light, but also with sound. This is common, can be easily seen during the day or the night. During the day, you may scream very loudly, but because it is hotter on the ground, hot air is warmed up and it goes and becomes cooler on the upper part. So the sound is refracted to the upper part, and that's why during the day it's not sound is not transmitted over a very wide area. At night, when it's cooler on the ground, sound is reflected on the lower side because it's a bit warmer on the upper part. So when sound is refracted, it can reach very far or can hear very far over far region. That's why maybe very early in the mornings, if for example you have the call for prayer amongst Muslims, it's very easy to hear that over a very wide region than during the day, maybe at around the lunchtime or in the evening hours around 4, because it is hotter during the day, so the sound is refracted on an upper trend. It will not be traveled as extensively as during the day. In the early morning, when the call for prayer is made, it can be reflected over a very wide area because of refraction. It's cooler. Sound can also undergo diffraction. Diffraction means sound or any wave moves around an obstacle. It is very easy for you to hear if I'm speaking in one class and you're in the next, because sound can move through the window or around the window and through the next door and someone else that can hear me. That is diffraction. Movement of waves around obstacles. And then sound can be interfered with. It's common during what you call, we used to have called radios. Radio, you may have some cases where you can get the sounds from 2 different radio stations at the same time because of interference. And interference can be what you call constructive interference or destructive. Constructive interference is where if those 2 sound waves meet, you can hear one much better than before. But where you can hear both of them or you cannot hear any sound because they have interfered with destructively, you don't hear anything. So let's not forget that sound, like any wave, has these properties. It can be reflected, hits an obstacles and comes back, we call it echo. It can be refracted, moves to the cooler part of air or a medium. It can be diffracted, meaning that it can flow around obstacles like through windows and through doors, and can also be interfered with, constructively or destructively. Now, sound, like all other waves, has speed. In our last class, we did come up with this formula. We said that speed is distance over time. This is something that we know very well. In the case of waves, speed is normally given by the symbol v. Distance is normally given by the symbol lambda, which means wavelength. And time is as such. Now that means, since we also know that time is the same as 1 over f. If we substitute this one with 1 over f, then our velocity or speed is lambda divided by 1 over f. And if you work this one out, it will be f lambda. And that is the speed of a wave is given by the frequency multiplied by the wave length, or frequency divided by the periodic time. Any of these 2 can be used to work out questions involving waves, and sound is a type of wave. So there are factors that affect the speed of sound in air, like wind direction, temperature, density, and all that. But generally, that is the way it is. So therefore, because of these differences and these factors affecting speed of air, of sound in different medium, if you have air at 0 degrees Celsius, its speed will be around 330 meters per second. When the temperatures increase to about 20 degrees Celsius, the speed also increases. That's how temperature affects speed, because molecules of air will be moving faster and faster, about 342 meters per second. If you were to lower the temperature to minus 10 degrees Celsius, it will be lower, and that's about 325 meters per second. What about in water? Fresh water at about 25 degrees Celsius, the speed is 1,497 meters per second. If you use seawater, which is a different medium, the speed will be about 1,560 meters per second, because there are more particles, dissolved solids. The more particles you have, the more vibration you have, and so the speed will be increased. In medium like steel, at 20 degrees Celsius, this is a solid, vibration is more and more because particles are closer, the speed is about 5,000 meters per second. A vacuum, where there's actually nothing, the speed is 0. Like you've said, sound waves can be transmitted, must be transmitted through a medium. Vacuum means there's no medium, there's no air, there's no liquid, there's no solid. So when there's no medium, when there's no material medium, sound cannot be transmitted and speed is 0 meters per second. Now because of what you know about the speed of sound, there's a concept that comes about, it's called the Mach number. Mach number is a relation between the speed of an object to the speed of sound. Speed of a particular object divided by the speed of sound, and this is normally in air. So when you talk about subsonic, it means the Mach number is less than 1. Speed of sound is more than the speed of the object. In the case of normal plane. Transonic, that speed is 1. Supersonic means the speed is more than 1. We have what we call supersonic jets, like the military jets. They move that fast. Hypersonic means the Mach number is more than 5. This is the case of a shuttle or rocket. So that brings us to the end of the first part of our lesson. We'll continue with more of sound in the second part.